Hello, welcome back. We are going to be doing Unit 6, Day 6. Your test is going to be on Friday this week. You do have a review in the homework, so make sure you're looking at that and getting prepped. We're going to start a little bit of trigonometry, and yes, trigonometry is used in a lot of higher level math, but there are definitely different sections as you go through math courses. It definitely applies, and you're able to kind of grow what you're doing with the math. We're going to start off with some basics. Again, we're getting near the end of the year, so we're just going to do some basics of some trigonometry. So trigonometry is doing math that you're able to calculate. And your notes are in Google Classroom right now. Missing sides and angles. So you're trying to find, you're finding out missing information that you might need to know. It may start off as a different shape, but you may break it down into chunks like a triangle. And what we're going to do is, and you can already see it on this paper, we're going to have triangles. We're going to work with triangles. We're going to work with specific triangles in ours, but you don't always have to. This is what we're going to do the last part of this year. It's like kind of like the last topic we're doing. So there are many different types of trigonometry. Some of them have nothing to do with shapes or anything whatsoever. But the type of trigonometry we're going to do, you will always see this in every problem we do when it has a shape. The aspect we're going to be working with is called right triangle trig. All right, so it's referred to as right triangle trig because every time you encounter a problem or any of the problems that we're going to be using information with, we'll always have that right angle box in there. Or if it's not in there, it should tell you there's a right angle or something along those lines. Now, a little bit of review from way back first semester, October and December, when we did Pythagorean theorem, when we did a squared plus b squared is equal to c squared. That c side was a particular part of the triangle. All right, that c is the longest side. That is our hypotenuse, and that is a special side to every right triangle we have, because it is always the longest side. No matter what, the hypotenuse of every right triangle will always be the longest side, or else there's a problem somewhere in the problem. There's an issue. So when you see every picture we're going to do in any type of trig, you will have a right angle. You're not going to be told which one's a hypotenuse, but you're going to have a right angle in every picture you're going to do these with for what we're doing. Now, when the situation happens like this, you can see the right angle, but I've already designated something else. This looks kind of funny. It looks like a zero with like a line through it. And this is going to be because we will always have an angle to focus on. So we're going to focus on a particular angle. Sometimes we might switch which angle we're working on. Now, when we do this, it's never going to be the right angle. The right angles, they're going to be to tell us we have a right triangle with a hypotenuse. But we're not actually going to use that right angle in our calculations. We're going to use one of the other two, and actually these are acute angles that we're going to focus on. From the angle we focus on, we're going to label the sides. And every time we say label O, A, and H. Okay, so they're not supposed to spell anything. O, like we abbreviate everything. O stands for opposite side. So opposite sides. And these are always in reference to a specific angle. And I'll show you more in a second. Okay, so opposite side to a specific angle. For example, if I'm looking at this angle right here, so we're not going to use the right angle. If I'm looking at this angle and I go across, something opposite you is on the other side. Excuse me. The A is going to stand for adjacent side. So adjacent, something is adjacent if you're sitting in a car next to somebody or in a movie theater. Adjacent means right next to you. If you're sitting in school at the lunch tables, when we were not in this situation, lunch tables or in classrooms, again, adjacent is either right side or left side. So they are right next to you. And looking at this triangle, I'm going to hold off on labeling the adjacent for just a second because I want to get to the H. And the H has already been identified here because that is always the hypotenuse of every right triangle. So honestly, sometimes that may be the easiest one to identify. So the hypotenuse, when we have the O side, the hypotenuse is that long stretch one here. So you label that H, the hypotenuse. Now, there's only 3 letters, and for a triangle, we have 3 sides. So if you have the O side identified, the H side, the last side we have is the A, the adjacent. So adjacent means this side is next to this angle. It just gets confusing because the hypotenuse is also next to the angle. So we don't have 2 adjacent sides. If you can label the hypotenuse first and figure out the O side, the adjacent side has to be what's left. Now, we label these because we are going to first set up ratios or fractions based on the triangles. And that's the first step. We don't need calculators or anything. We're just going to be able to set up problems. That's our first step to be able to do any sort of trig here. We need to set up the problems. So when we look at this, and there's 3 words here, SINE for sine, cosine, and tangent. If you look at a calculator, this looks like sin. They abbreviated it. Cosine looks like cos, but it's cos. And we'll get it in the calculators the next time class for next week. Tangent is tan. Okay. No matter if they're the full word or the abbreviation, we have certain patterns we're going to follow. So if you like the patterns in math, here you go. Sine is going to be the opposite side over the hypotenuse every time. So that's why it's important to be able to label them so we know what side's what. So sine is the relationship of the opposite side over the hypotenuse. And we'll go through a couple examples here. Cosine is a different combination. It is the adjacent. So the adjacent side over the hypotenuse. And tangent is the combination of opposite over the adjacent. Now, of course, I'm not going to write out these words every single time. There's an abbreviation for it, just like PEMDAS and some other things you've probably done. Just like LOL, that sort of stuff, we abbreviate this. And we use this all the time, and if you talk to anybody else who's ever done trigonometry, they're going to know exactly what you're talking about. It's SOH for sine is opposite over hypotenuse. Cosine is adjacent, so A over H, CAH, and TOA. Tangent is opposite over adjacent. So if we say this, and I'm going to say when we get a little bit more into this, it's said SOHCAHTOA. SOHCAHTOA. Okay, it's just the abbreviation. This doesn't change at all. I'm not going to say, hey, when we do this, we need to modify this and change it to this. This is how it's going to stay every time. SOHCAHTOA. Now, there are other trig functions we're not getting into because that would take more time. And again, we're near the end of the school year. So, but there are other trig functions besides these three, but we're just going to start with these ones. Okay, so I'm going to do SOHCAHTOA, and it says, use the triangle to identify the ratios, which means I want to set up the O and H, A and H, O and A for the sine, cos, and tan. Now, kind of going back to the beginning, I need an angle to focus on. It is not going to be the right angle here. The right angle is just to tell you it's a right triangle. In terms of the angle, you're going to be told either a letter or the degree measure. And I'm going to do these in columns. So these all reference angle Y. So focus on angle Y. Okay, so I'm going to circle the angle Y. As I said, I'm going to ask you lots of times, label O, A, and H. O goes across. So this is my O side. The H side, the hypotenuse, is always the biggest side. So if maybe you want to label that first, you look at the numbers 4, 3, and 5. It has to be the biggest side. Or it's that big slant in there. And the A is the number or the side that's left. So you have everything labeled. All you need to do is take the numbers from here and make fractions with them. So sine, I need the opposite number over the hypotenuse. So literally put them in fractions and you're done. 3 for opposite, 5 for hypotenuse. Cosine, I need to put adjacent over hypotenuse. 4 and 5. Tangent, I'm going to make a fraction putting the opposite over the adjacent. So it's really, right now, it's as much as putting them in fractions and we are done. No more. You don't have to do anything else. Okay, so those are done. Now, the thing comes when you look over here, these reference a different angle. So on this one, I'm going to focus on the angle Z. Well, when I go back to my picture, Z is over here. Okay, so I'm not focused on Y anymore. When I do angle Z, the opposite is across here, and that is the A, which is to the opposite for this angle. I can't have two O's, and the hypotenuse still has to be the biggest side. So the opposite has to switch when I switch angles. So the opposite and adjacent switch each other when I switch the angles I'm focused on. Once you get that, again, it was just identifying which is which. Go through and say, okay, O and H, again, sine from Z is O over H, so 4 over 5. Cosine is the A over the H. A over H, so 3 over 5. Tangent is the O over the A, so 4 over 3. And that's all we're doing. Next week, we'll get into how do you work with these things after we have the setup. What do we do? But for now, all you need to do is set them up. And same thing on this next one. So if you want to pause it and then double check back here, I'll go through. So first thing I'm going to do is focus on L. So L. My opposite side is 7. Hypotenuse is the biggest number. Adjacent is what's left over. All right, so SOHCAHTOA. So sine is going to be the fraction of 7 over 25. Cosine is 24 over 25. And tangent is 7 over 24 because opposite over adjacent. When I switch over to N, switch to angle N, I go across. Here's my opposite side now. So I take that and put my opposite there and my adjacent there. So opposite is 24 over 25. Adjacent and hypotenuse is 7 over 25. And now tangent from n is opposite over adjacent. So 24 over 7. So we're just going through these patterns. You can see on your homework that practice cross multiplying, getting ready for your test. Sorry, this is not on Thursday. This is on Friday. Your test is on Friday. Setting these up, figuring what should be comparable, cross-setting fractions up, cross-multiplying. Again, similar problems, compare the triangles. Are they similar based on the sides or not? And then you have some trigonometry at the end where you're just setting up the ratios and the fractions. Let me know if you have questions. Have a good day. Bye.